The second element that you need to go over the merger simulation section in the notebook is the use of pandas. So basically we want to make a data frame with some observations that we're going to generate ourselves, and then we're going to manipulate the data frame and make a plot of the results. So first of all, we're going to generate a number of costs draws. So we're going to have random draws, so we're going to use TensorFlow, but you can use any other library you want. In the notebook we actually use PyMC3. So we're going to draw from the normal distribution. And now the dimensions of our draws are going to be 50 by 2. So the 2 is for the two firms, so we're going to draw cost levels for the two firms, and we're going to do this 50 times. So we're going to have 50 different observations, 50 different states of the world, if you like. And in each of these 50 cases, we're going to draw two cost levels for our two firms. We're going to assume that the mean cost level is 0.2, and we're going to have a standard deviation of 0.05. And to get a simpler representation of that factor, we're going to use NumPy. So the output level of firm 1 is now going to be equal to, so again we're going to use the optimize fsolve function from SciPy. And the thing that we're going to solve is also as above. It's a function of x. We're going to solve fixed point. And fixed point has as an element x and costs. And cost is now indexed by I because we have 50 different costs. So fixed point is a function of this. Then fsolve also needs to have our initial guess, and since this is two-dimensional, I'm going to give it two guesses. So it's going to solve in one go for both Q1 and Q2, but here I'm only going to be interested in Q1, so I'll give it the index 0, and we're going to do this for I in range 50, because we did 50 draws. And of course the corresponding result for firm 2 is very similar to this. The only difference is that when I solve it, I need to have the second element of that solution, which corresponds to the output level of firm 2. So let's see whether we don't get any errors. No, that seems to be working fine. So now I can start creating the data frame. And for that we're going to use the pandas function, data frame. And the way that function works is I'm going to give it a dictionary, which first gives the name of the column, and then it gives the vector that corresponds to that. So let's call the first column C1, so that will be the cost level of firm 1. So I'm going to take this vector costs. For that vector I want to have all the rows, so that corresponds to the colon. And then I only need the first column, because that corresponds to the cost level of firm 1. And then the cost level of firm 2 is similar. So that's going to be costs. Again, I want to have all the rows. Oops, I did the wrong brackets here. I want to have all the rows, but now I want to have column 2 for C2. Then I'm going to create a column which is the output level of firm 1, which is simply Q1, which we just defined above. I'm going to have the output levels of firm 2, which is Q2, which is indeed the vector Q2. Now I close the dictionary, and here I close the command of the data frame. So just to make sure that we get what we're expecting, let's look at the first couple of rows of that data frame using the head method, and that looks all fine. So now we can start manipulating the data frame. So what I can do is I can define a new column in the data frame. I call it capital Q, so there's going to be, it's going to be total output. And that's going to be equal to the sum of Q1, which is the output level of firm 1. And I can use this notation, but I can equivalently also use this notation, so I'm going to mix it here. It's no problem at all for pandas. So I'm going to sum the column Q1 and Q2 to get the column capital Q, total output. And if again we do a head, you see now that we've added this new column, capital Q, which is the sum of these two columns of Q1 and Q2. So in a similar way we can define the Herfindahl index. The Herfindahl index is just the sum of the squared market shares of the different firms. So I can add a new column, I call it H for Herfindahl index. And it's going to be equal to the output level of firm 1 divided by total output level. And we're going to square this. So this is the market share of firm 1 squared plus, similarly for firm 2, dfq2 divided by df.q squared. Yep, we get no errors. And then finally what we can do is we can actually plot this. So I can use plt plot. And the thing I'm going to plot is on the horizontal axis I'm going to plot total output, and on the vertical axis I'm going to plot the Herfindahl index. And I'm going to add this. So at home you can try what happens if you delete this last part. You get a very weird plot, so that's why we want to have a scatter plot. And here it is. So here you see the relationship, and you can add here on the horizontal axis Q as a label, and on the vertical axis you can add the Herfindahl index as a label. And this gives you the plot between total output and the Herfindahl index. In the notebook, actually, you're going to be asked to plot the Herfindahl index versus the price in the market. And then you're going to interpret that in terms of the merger simulation.